Moving forward, going to question number 8. In this question, we have to find unit digit in the expansion of this number. So before we take up this problem, there is one important concept. You might find that concept a little cumbersome as such, but very useful in solving many divisibility problems, finding unit digit problems, finding remainder problems. So just it would appear to be very complex, but it is not as complex as you might think. The concept is called binomial expression. As you can see in the name itself, the name says by 2. This expression will be involving two entities, right? So what it is about is, if we have a number x plus y, an expression x plus y to the power n, this can be expanded in this form. X to the power n minus r, y to the power r. So if I write it term by term, this is how it will look like. This is how it will look like: n0 x to the power n y to the power 0 plus nc1 is 1 y to the power 1. Do not fear this expression, that is x to the power 0 y to the power 1. Do not fear this expression. How many terms will be there in this expression? Just look at this. How many terms will be there in this expression? Just observe the power of x. It is varying from n, decreasing up till 0, right? So n plus 1, x is coming in this expression. X n number 1, n plus 1 times. It means this expression has n plus 1 terms, right? This nc0, nc1, ncn, they are called binomial coefficients. Binomial coefficients. The expression for that is, what actually in number form it denotes is that factorial n divided by factorial r into factorial n minus r. You might have encountered. So what factorial n means is that, you might have seen this before, but for those who have not seen, who have not come across this factorial expression, is that factorial n implies multiplication up until n, as in multiply all the numbers, natural numbers, which are coming before n, and also including n. So this is what it is, right? How is this expression useful? We'll just see. We have been given, let me copy that expression 57242 57242 to the power 9 into 7 into 5, 9 into 7 into 5 into 3 into 1, right? Just observe this. We have been asked to find unit digit, right? So just observe this. Can we write this number as 57240 plus 2 to the power 9 into 7 into 5 into 3 into 1, right? If we are expanding this using binomial theorem, what we will get is that this will be something like this. For a moment you can multiply. Let's multiply this. If you multiply this, what we are getting? 15 into 63, right? So this is what we are getting. We'll write just the way, no further multiplication because it is going to consume our time. So we'll just write this in this form only. This C0, right? First term will be this C0 into 572 57240 to the power 15 into 63 and into 2 to the power 0, right? Next term we write 15 into 63 C1 57240 to the power 15 into 63 minus 1 into 2 to the power 1 plus the last term would look something like this. 15 into 63 C 15 into 63 57240 to the power 0 into 2 to the power 15 into 63. And one last term before this would look something like this. 15 into 63 C 15 into 63 minus 1 57240 to the power 1 into 2 to the power 15 into 63 minus 1. So this will be just penultimate term here. Now what I am asking you to do is that you just observe these terms you observe all these terms up until the penultimate term. What we are saying is that we have 0 and power of that greater than 0 नहीं रन रही है. So any number which has unit digit as 0, and if you power that number with a number greater than 0, then that number which you will be finding will always have 0 as at unit place. So no matter what the number is, if the number has 0 at the unit place, it will not change the other number which is adding to this number, which will have unit place number other than 0, let's say 1 or 2 or something. If we add these two numbers, then we'll be getting digit unit digit of the resulting number same as the other number which has unit digit. So that's why I've done this. So what we'll be doing is that we'll not be looking at this remaining numbers, we'll be just looking at this number, this term which will have unit digit. So 15 into 63, see 15 into 63, 2 to the power 15 into 63, because something to the power 0 is equal to 1. So we'll just look at this expression. So this is nothing but 15 into 2 to the power 15 into 63. We can easily find unit digit of this number. How? So cyclicity, observe this, 2 to the power 1, 2, 2 to the power 2, unit digit 4, 2 to the power 3, unit digit 8, and 2 to the power 4, unit digit 6. Now 2 to the power 5, unit digit 2, repetition after 4, the cyclicity is 4. So if we divide this number by 4, what can we get as remainder? Possibility is, as remainder we can get 0, 1, 2 or 3, not more than that. So whatever the remainder will be, if we are powering that, and whatever the unit digit we will get, it will be our unit digit. So certainly not we'll be taking 2 to the power 0, sorry, in case of 2 to the power 0 we'll be taking 2 to the power 4. Getting my point? So moving on, (15 into 63). 63 can be written as 60. 16 can be written, 63 can be written as 60 plus 3 into 15 to the power. To the power 15 into 60 into 2 to the power 15 into 3. This is nothing but equal to this. Here this is divisible by 4. Now check this. 2 to the power 15 into 3 is 45. 2 to the power 45 is 44 plus 1. This is divisible by 4. So we are left with 2 to the power 1. So the remainder will be 2. Sorry, unit digit will be 2. Unit digit. We are done.